Hey everybody, it's great to be back. Today I want to talk about GraphQL servers, but specifically about building TypeSafe GraphQL servers. So the agenda is, first, I want to talk a little bit why type safety matters, and specifically why type safety matters for building schema-first GraphQL servers. We'll look into a tool called GraphQL Gen, which allows you to build TypeSafe GraphQL servers, and we'll also see that in action in a live demo. And afterwards, we'll also see the benefits of TypeSafe database access, what you can do with Prisma. So my name is Johannes Schickling. I'm the founder and CEO at Prisma, where we're building tools around databases and the data layer for modern applications. If you want to follow me on Twitter, you can see the handles on the slides. At Prisma, we are building the Prisma Client, which is an auto-generated type-safe client library for your database, which you can think about like as a replacement for ORMs which scale. We're building Prisma Migrate, which are declarative migration tools, and also Prisma Admin, which you can think about like as a modern version of PHP Admin. So let's get to the meat of this talk. Why type safety for GraphQL servers? So generally, why type safety matters is I think type safety is one of the most underappreciated tools in the tool belt of a modern web developer. And I think it's just seeing like a bit of a renaissance right now. And the big benefits you get with type safety is like that you can catch errors at development or build time instead of detecting them in production and causing downtime. So this way, if you're using type safety in your development, you can move fast, build and ship features fast with confidence, with feeling good about not breaking stuff. It also, if you just care about a better developer experience, type safety enables that. Type safety gives you auto-completion, especially with VS Code, makes it so nicely integrated. And for the JavaScript developers amongst us, and this is what my talk will also focus on today, I would go as far as saying like that TypeScript is really becoming the new default, both for APIs that you're building, projects that you're doing, but also for new libraries. I think every tool of Apollo is, for example, also in TypeScript. So if you've kind of still have like a bad feeling about like maybe you've used Java in the past and you remember all of this huge boilerplate, or if you've used Flow for React, but that didn't really wasn't really quite worth it for you, I would really encourage you to check out TypeScript because it kind of gives you the best of all worlds and has just such a fantastic ecosystem. So that's a general pitch for type safety in TypeScript, which we'll look into today. But let's talk about GraphQL servers. So generally, there are two ways of building GraphQL servers. And I think in this conference, we've already seen a couple of these. So there's the resolver-first approach, and then there is the schema-first approach. And we'll now look into both of these approaches and see what the differences are. So the resolver-first approach, for example, which is used by GraphQL Ruby, or if you're building a GraphQL server in Scala with Sangria, or with Graphene in Python, that's using the resolver-first approach. And the idea here is that you basically define your entire GraphQL schema just in your own code, like in Ruby or Scala, and based on this code that how you're defining your resolvers, that actually you derive the GraphQL schema from that based on introspection. So your resolver code is the source of truth. The alternative to that, which is the schema-first approach, turns it the other way around. And you're writing first your GraphQL schema definition using GraphQL SDL. And you use that kind of like as your contract to now implement your resolvers. And this approach is very, very prominent in the JavaScript ecosystem, but also in Go, for example, with GQL Gen. And this is the approach I want to focus on today, since I think most of us here have used this approach. And I think it's a great approach. It just has also brings a couple of problems with them. And this is what I would like to talk about. So I'd be actually curious, who of you has built a GraphQL server with a schema-first approach? OK, great. So I'm pretty sure that a lot of you have run into some of these problems that I'll show you in a second. So here is a relatively simple GraphQL server. So on the left, we see the schema definition in GraphQL SDL. And on the right, we see the resolver implementations. It's a super simple application. We basically just have a user type here, and you can query for who are you as the authenticated user. And we have a login mutation and a sign-in mutation. And the implementation is fairly straightforward. Just assume that the functions that are used here, that they actually do what they're supposed to do. But there is a catch. In this little code snippet here, there are actually 4 bugs built in. So, and all of these bugs could have been caught by better tooling. So I want to use a couple of seconds to just give you a couple of seconds to see whether you see at least 2 errors. And if you do, raise your hand. All right. Imagine now that's your job on a daily basis. And I'm pretty sure that you've all spent a lot of time looking for a bug, or then you just run into this in production. And I think we can all save a lot of time if we have better tooling that helps us solving these problems. So let's take a look at some of these problems that we have in here, since some of them are more obvious, some of them are fairly subtle. So first one is here for the login mutation. The mutation in our SDL actually wraps the input arguments in an input object. Here in our implementation, we're using the args.username directly. So as soon as you would have run the login mutation, you would have caught that, but still would have been nice if tooling would have helped us here. Another even more obvious error is we forgot to implement the sign-up mutation in the first place. Again, if we want to try it, then we would have caught this. But here, 2 a lot more subtle mistakes. So if we look here at the profile picture URL, which returns a string, and a non-nullable string, if we're comparing this to our actual implementation, if we say here in the data, if we don't have the picture ID, then just return null, we would probably not have a test for that, and it would just pop up in production in the edge cases, and it would blow up. If we would have a type-safe system that would tell us, hey, you're never allowed to return null here, that would be a big benefit. And here's the last mistake. I think that's the most subtle one, but also the most dangerous one, as we're kind of relying on building GraphQL servers in JavaScript. We're kind of relying on this concept of a default resolver. So the concept of a default resolver is basically, in the most naive way of how you build a GraphQL server in a schema-first way, is that you basically say for every field that you've defined in your GraphQL schema, in your type, you also need to implement a resolver function. But that would mean we need to, if a type has 20 fields and all of them are scalar values, we need to implement basically 20 identity functions, and that doesn't really makes a lot of sense. So what the GraphQL engine in JavaScript basically does is that it says hey, if the data is a one-to-one mapping to our GraphQL type definition, then you don't need to implement it, then it will just work. The problem is if it's not a one-to-one mapping, but we kind of think it is a one-to-one mapping, then it just blows up in production. And that's the case here. So if we're looking back here into the query implementation where we return a user, and the user is now passed into the user resolvers, here we're kind of assuming for ID, username, and name that there is a default resolver. That is the case for ID and name, but it's not the case for username here, because the username in our schema is camel case, and our data, for whatever reason, is all lowercase. So, and that will just blow up in production. I'm pretty sure a lot of you have had a similar situation in the past and you've just like scratched your head what's going on. And all of these problems that we've seen can be solved through better tooling. So the problem here is really like these inconsistencies between your GraphQL schema that you've defined and your actual resolver implementation. And you can either fix them like as they pop up and you're gonna get paged in the middle of the night, or you find them like at development time, at build time. And you can do so using type safety. So let's think about like how can we create a type-safe mapping between our GraphQL types to TypeScript. And TypeScript here is just an example. You could also use Flow or whatever other language, but we're using TypeScript here. So the idea is to create this mapping into TypeScript interfaces and then let the TypeScript compiler or VS Code, for example, let it help us to basically let it tell us which things we need to fix. So the idea for this mapping is like that based on a GraphQL type definition here, for example, a type query with a hello field, we would create the following interface. So where it just like maps one-to-one all the things like the name, its arguments, the return type. And now that we have this interface definition, we now need to import it and implement it in our actual resolvers. And just by doing that, now the type system can basically help us to avoid mistakes. So let's take a look at a couple of these mistakes that it avoids. So for example, if we're having here, for whatever reason, we haven't implemented the hello resolver, then VS Code will tell us like, hey, the hello resolver is missing. Please implement it. And it wouldn't even allow you to build and start your GraphQL server. Another common problem is if you want to access an argument that doesn't exist, we'll also tell you like, hey, there's just a name argument available. Another common error is, or a little bit more subtle but also pretty dangerous, is if you would return a value of a wrong type in your resolver. Again, here the type system can tell you, hey, here for hello, I'm just expecting a string. Boolean, that doesn't work. And all of these problems are now like caught by the type system. So again, the idea is we would basically translate our GraphQL schema into TypeScript interfaces, implement them. But the problem now, if we would do that manually, this is a fairly super small GraphQL schema. If we would now do that for a more real-world GraphQL schema, then we're gonna end up with a huge file that we manually need to maintain. And that might arguably even be worse. Like, if you're kind of relying on like a type definition that you've created for yourself, you kind of feel like safe, but probably you've made a lot of mistakes by creating these type definitions in the first place. And it's just a lot of work. So, and the solution to this problem is that we're gonna use code generation. So we're basically going to use a tool that automatically maps the GraphQL schema definition into TypeScript interface definitions and automatically handles that for us. So for those of you who are new to the idea of code generation, it's basically like this automatic concept that something gets regenerated for you. This code, you're not supposed to edit this code. You're just supposed to import from it. And maybe if you hear about code generation, don't confuse it with code scaffolding, what you might be used from like Ruby on Rails with like the Rails controller scaffolding. The difference for the scaffolded code is like the scaffolded code will be your code and you need to change it. The code generated code is rather sitting on the side. It's basically like doing the magic, but you can look into it if you need to understand it. So that's basically it. The concepts are how we want to solve the problems that we have with schema-first development is combining type safety and code generation. And that's exactly what GraphQL Gen does. So GraphQL Gen, I think we officially released it last week. is meant for schema-first GraphQL servers and makes everything around your GraphQL server type-safe. So your resolvers, your arguments, your models, and since it's based on CodeGen, you don't need to write any boilerplate. So GraphQL Gen is a fairly simple and lightweight tool that works with all the existing JavaScript ecosystem. So it works with Apollo server, with GraphQL Yoga, with GraphQL tools, and you can use it both for building your own like GraphQL native monolithic applications, or you can use it for making your GraphQL gateway type safe. And I think the neat trick here is like that GraphQL Gen doesn't really do all of the hard work. It's rather that it provides the foundation that the TypeScript compiler can do all of the hard work. So how it works, just as we've seen before, we have our GraphQL schema definition, we generate interfaces, we need to now implement these interfaces, and the workflow looks basically like this. You have your schema, or you have a schema change, you run GraphQL Gen, and then basically the TypeScript compiler tells you whether everything is good or whether you need to change something. And yeah, then you can make, again, changes to your schema. So to get started, you can either use this for building new GraphQL servers from scratch. So you can bootstrap a new GraphQL server with already everything set up. Or you can add it to your existing project by simply installing GraphQL Gen either as globally or adding it as a dev dependency. You can initialize your config file using GraphQL Gen init, and then you basically just start importing these TypeScript interfaces in your resolver implementations. So the config file looks something like this. So you need to specify your language. You need to specify where your GraphQL schema lives. You can point to a context definition. The context is basically the thing that's passed into every of your resolvers, and you can also make that type safe. And you need to provide mappings to your models. So maybe not all of you are familiar with the concept of a model. A model is basically the thing that you return in a resolver that's passed in as a parent value in another resolver. So you're probably familiar with your GraphQL schema and your resolvers, and a model is just like a term of the data that you return in one resolver that's passed into your other resolver. And you're also supposed to have type definitions for that to make the mapping inside of your resolvers also type safe. So yeah, that's basically everything you have to know. Let's take a look at an actual demo of how this works. So in this demo, we're going to look into an existing GraphQL server that I've prepared. Has a few bugs, which we're going to use GraphQL Gen to help us find them. So we'll introduce GraphQL Gen, fix these problems, and then we also going to evolve the GraphQL schema a little bit and see the workflow of that. So let's do that. Hopefully this is big enough. So, and I hope the contrast is good enough. I can also switch this to the light theme. It's not my favorite, but might be a little bit more visible. So this is super simple GraphQL server. So here, let's take a look in the index file. Here we're simply starting a new GraphQL server. It points to our GraphQL schema, points to the resolvers, and also passes here a data object into the context. So the data object here is basically just a replacement for our database. It's basically just like a couple of variables that mock our database in this implementation. So if we take a look in our GraphQL schema, the GraphQL schema looks like this. We have a super simple logging application where we can query for a feed, for some drafts. We always get like some posts returned. And we have a couple of mutations here. A post has an ID, title, content, whether it's published, and it has an author, and a user has an ID, name, and their posts. So super simple. Let's actually fire up that GraphQL server and see whether it works. So we're just going to open up the the GraphQL playground here. We can now query for the feed. Let's get the title, the ID, and the content. We can query for this. Perfect. So we're already getting back some data. Let's take a look in how the query is implemented. Just as simple as this. We're just accessing the data object here on our context, and then just filter the posts whether they're published or not. All right, so in our GraphQL schema, we also see the field here is published. So let's also query this. And OK, now we are running into a problem. So why is this? So here we are basically returning a post. So let's take a look in the post resolver. Our post resolver looks like this right now. So we basically just implement the author resolver, and we are kind of relying on the default resolvers kind of doing the right thing. So if we now, again, to recap the concept of a default resolver, it works for so long that your data that you're returning actually matches the GraphQL schema. So if we take a look here into like what a post here looks like and what the data we have available here, we have ID that matches, title matches, content matches. OK, so here we have published, and here we have is published. So this is already something that we've just now kind of seen in production, that this where it breaks down. So let's now introduce GraphQL Gen and see whether it can help us with this. So we simply do so by adding this GraphQL Gen YAML file here. I've already added it. So I've configured TypeScript, pointed it to the schema, pointed it to the context definition, and wired up the models. So the models are basically just here in this types file, just a TypeScript definition for what our data actually looks like. And that's basically all we need. Now we can run GraphQL Gen, or short GG. And that basically generates over here, generates the type definitions for us, which we can now use, for example, here for the post resolvers, which we can now use in our post resolver and implement our resolvers with it. So I've already added this here. Now we just need to say here post resolvers .type. And now we already see, OK, we get an error message here. Property ID is missing. OK, so this would basically now force us to implement all of the default resolvers. But there's a shortcut for this. So we can basically just, since GraphQL Gen already generates the default resolvers for us, we can just now mix them in here. The next problem that we see, property is published is missing. And that makes sense. This is not part of the default resolvers here. The default resolver is kind of this intersection of your GraphQL type definition and the data that you have actually available. So that makes sense. We need to implement the isPublished resolver. And the cool thing is we already get auto-completion here for isPublished. We can now just say here, we just return published. And you see here, we're also getting auto-completion here for the parent value, since this is typed based on the model that we've injected. So now we save this. We no longer get an error message. We can start the GraphQL server again. And now when we query this, it works. So this has already helped us to find the problem. And the really neat thing about GraphQL Gen is as well that we've just seen now that we can incrementally adopt this. So on a resolver by resolver level. And it already helps you to find problems. Let's do this also for the query resolvers here. So let's do it. Let's just import it. OK. And now we also get an error here. And we already see it in here, post ID. Post ID does not exist on type args. And that makes sense if we take a look again in our GraphQL schema. In our GraphQL schema, we have here post ID. And here we're kind of accessing args.postID, which doesn't exist. So let's see what we have available here. We have available here ID. So let's save that. And the server is running again. So GraphQL Gen, like one step at a time, tells us about the inconsistencies between our GraphQL schema and the resolvers. So, and you can use GraphQL Gen to initially find problems, but also to evolve your schema. So let's say we would add a slug field here. We would now save this, run GraphQL Gen again. And if we now go back to our posts, this will now tell us, hey, we didn't, on our data, we don't have a slug. So it forces you to implement the remaining resolvers, which we can just do like that. So let's say this is the title to lowercase, and everything is happy again. So that is basically how you can introduce GraphQL Gen in your existing project, and how it helps you to find a lot of these problems. Yeah, so let's get back to the presentation again. Perfect. A few thoughts on the future of GraphQL Gen. GraphQL Gen is heavily inspired by an equivalent tool in Go called GQL Gen, which is kind of like a sister project now, where we are taking a lot of inspiration from, and we're trying to evolve the roadmap in a similar fashion. And based on that, we also want to add support for an integration system or a plugin system that allows you to, for example, talk to gRPC services or Swift services and map that together in a type-safe way. We also want to add support for other JavaScript-based languages, for example, for Reason. Yeah, so I think there are a few really interesting ideas. So if you're interested in contributing, also please get in touch. So the last thing I would like to talk about is kind of what I see as the holy grail for modern developers, which is the idea of end-to-end type safety. So especially for in the GraphQL space, we've seen, I think, a couple of talks about why that's interesting. And the idea is basically that you have a type-safe mapping from your row as it lives in your database up to how you can access your data in your React props. And very often, it's not a one-to-one mapping, and you need to map it somehow differently, but you still need to do the mapping in a type-safe way. And that's the idea of end-to-end type safety. And I think the biggest missing piece here is, if it goes through one step at a time through the stack, Apollo CodeGen already helps us to have a type-safe mapping from our GraphQL API into our front-end applications. GraphQL Gen helps you for your GraphQL server and Node to make that type-safe. And the missing piece is basically how do you access your data from your database in a type-safe way. That's exactly what we are doing with Prisma, which gives you type-safe database access. And that's a pretty big deal, because this API to database mapping is, I think, one of the most brittle and error-prone things that you have to do as an API developer, and one of the most common causes for downtime in production. And the way how you typically tackle this is just by writing a lot of integration tests, and these are, it's kind of ugly to test, and most of them you can just they become obsolete if you have type safety for that part. And that's what we're enabling with Prisma. So with Prisma, you can basically auto-generate a type-safe database client for any kind of language, for any kind of database. So you can either use your existing database and introspect that, or you can start from scratch and evolve your database on your own. And Prisma generates that client library for you, and Prisma's query engine allows you to efficiently resolve data from various data sources. So, and Prisma is especially interesting for building GraphQL servers because Prisma Client already has a built-in data loader that solves the N+1 query problem for you, and also makes it super easy for you to implement common API features like filtering, pagination, CRUD functionality, and even its real-time layer makes it easy for you to implement your own GraphQL subscriptions. On a high level, Prisma works like this. For an existing database, for example, that you connect it to your database, you introspect your schema, you generate a client for that, and then you basically start building your API. Yeah, so this was a high-level overview over the concepts of type safety, end-to-end type safety, and for building GraphQL schema-first GraphQL servers. Few key takeaways for you. Basically, I think it's interesting to think about as you're building a new GraphQL server about the two different ways of doing it, schema-first and resolver-first. Both have their advantages. I think we're going to see a lot more in both camps. If you're going schema first, then I would really encourage you to give TypeScript a chance and use GraphQL Gen to let it help you solve a lot of these problems during development time. And if you want to go all in on end-to-end type safety, check out Prisma, which gives you TypeSafe database access. Here are a few resources. You can find GraphQL Gen on GitHub, also a couple of examples for that. And yeah, two more things. One, if you're interested in working on this sort of tooling, working on database tooling, API tooling, we're hiring, so feel free to check out our jobs page or talk to me afterwards. And it would be awesome to see many of you in summer in Berlin next year, where we are organizing the GraphQL Conf. The CFPs are open now, so if you're interested in giving a talk yourself there, feel free to submit a talk. And yeah, that was it. Thank you so much.